So number three, an open top water tank is in the shape of a cuboid. So let's draw that already. That is not a very good shape for a water tank, but anyways. So you have a water tank in the shape of a cuboid, which is basically this. It's basically a box, like a like a carton of milk. All right, and it doesn't have any top. Okay. All right. So next, the tank has a square base of side length S. So the base of this thing is actually a square, and it has side S. So all of these sides measure S meters. And we know the volume of this tank to be 216 cubic meters. So the volume is this much. All right, so let's continue. They're asking me find expressions in terms of S for A, the height of the tank. All right, the height. How can I get the height of the tank, which is this much, obviously, in terms of S, which is the side of this square? Okay, all I need to know is this, guys. The volume of any box, any box, is the area of the base. Let me actually write that down. The volume is the area of the base times its height. All right. And since I know that the base is a square of side S, therefore the area of the base of this particular box or tank is S squared times the height. And we also know this. We know that the volume is 216, so we can plug it right here. 216 equals x squared times height. Let me flip the sides. And finally, let me put h, which is the height of the tank, as 216 over s squared in order to achieve the solution of the first question. I have already written the height of the tank in terms of s. This is the solution. Next, B, find an expression in terms of S for the surface area of the tank, el área superficial. Okay, so what is the surface area? It's basically, guys, the area of the base plus the four walls. Like this is the first wall, this is the second wall, this is the third wall, and the fourth wall. So we have four equal walls because I mean you must notice that they are the same wall, the same rectangle, plus the area of the square. So let me put it this way. Let's write AS for surface area, right? Surface area. And that's going to be equal to the area of the square, which is S squared, plus 4 times the area of a single rectangle of these ones. And as you can see, the area of this rectangle is H times S. There you go. Okay, so this is the surface area. But since I know H to be in terms of S, I can put it right there. So let's do it. And then simplifying just a little bit, we're going to be getting 4 times this number. That's going to be 840. I think it's 864. I'm going to confirm in a moment, but I think that is, yeah, it's correct. 864 over S. And that's it. I have accomplished the solution to letter B, which is, once again, writing an expression for the surface area of the tank in terms of S. As you can see, everything here is in terms of S. Okay. Now C, given that the surface area of the open top water tank is minimized, find the value of S. Okay, once again, so basically we want to minimize this quantity, guys. This is a function of S. So let me declare that. Let the surface area be a function of S. So the function is this, S squared plus 864S. And basically we want to minimize this function. It's the same as before. We find the critical points and we do the whole stuff. So let's do it. You're gonna be getting this 2s minus this. We make this equal to 0. And then we multiply by s squared. And then we solve for s, which is gonna be 432, and we take the cubic root of that. Okay, so s needs to be the cubic root of 432. Let me calculate how much that is. Just an approximation. That is about 7.5. All right, and then once again, all you need to get the second derivative. I'm going to do that in yellow here. Getting the second derivative of the function, that's going to be equal to 2 and minus 2 times this over s to the cube. It's going to be plus. Okay, make sure that this is the second derivative. Please make absolutely sure of this. So this is the second derivative, and we want to evaluate in this value, 7.5. Well, close to 7.5. And you will get that the evaluation is clearly greater than 0. And if that happens, then the critical point is a turning point, and it's a minimum. It's a minimum. Okay, so that's it. Now let's make a confirmation. Let's actually put the function, which is this one right here. This is the function for the surface area. Let me put it in Desmos, and let's see if in fact for this value of s we get the minimum of the function. So let's do it. S squared plus 864 over s. Let's do it. I'm gonna put y. I already forgot the s squared plus, okay. Okay, so that is the function. Let's see how it behaves. There you go. Okay, as you can see, the function is decreasing, and it finds its minimum at 7.5, just like we predicted, right? And then it increases again. Obviously, this part of the function is completely meaningless because there is no point talking about negative s. So there you go, guys.